Hi, I'm Chris, and this is Computing with Chris. Like many families right now, our family has been playing a lot of board games. For example, Ticket to Ride. Ticket to Ride is a very popular game. If you're not familiar with it, this is what part of the board looks like. Right now we're just kind of looking at the southwestern quadrant of the United States. And the goal is to connect cities together using train cars. So each rectangle can take a train car. And so, for example, if you wanted to connect Denver and Santa Fe, you would put train cars on this little route here from Denver to Santa Fe, right? And so on. And an interesting question to ask is, well, if this game is about connecting cities, if I wanted to connect all of the cities in a certain area, so here, like if I wanted to connect San Francisco, Omaha, Houston, El Paso, Santa Fe, all these cities together, what would be the minimum number of train cars that I would need to make it possible to travel from any city to any other city? Now, that doesn't necessarily mean that I have the optimal route between any pair of cities. So for example, here, it's true that Kansas City is connected to Denver, right? Because I can go Kansas City to Oklahoma City to Santa Fe to Denver. But that's certainly not the most direct route. But that's okay. We're not interested in the most direct route. We're just saying we want to make it so that there is some path from every city to every other city in our little part of the map here. This turns out to be one of the classic problems in computer science. It's couched in the branch of discrete mathematics called graph theory. The problem is called the minimum spanning tree problem. And there's a clever algorithm to do it called Kruskal's algorithm. Well, actually, there are multiple algorithms, but Kruskal's algorithm is the one that we're going to cover today. And it's actually pretty simple and it's pretty interesting, I think. And we're going to do it without any computers. But we will need something. I'm thinking we need some more Chris's. This is Foxglove Chris. He's writing down all of the direct city-to-city routes in order from the shortest, like Omaha, Kansas City, and Dallas, Houston, up until the longest ones. Like here, I think the longest ones are Phoenix, Denver, and San Francisco, Salt Lake City. So those will be at the end of the list. Now, obviously, there are ties, but that doesn't matter. Foxglove Chris can put the ties in any order. Thanks, Foxglove Chris. This is Oven Mitt Chris. He's all thumbs, but that's okay, because his job is just to tell us whether there exists a path from one city to another. So for example, hey, Oven Mitt Chris, is there a path from Denver to El Paso? Is there a path from Phoenix to El Paso? What about from Dallas to El Paso? Thanks. With the help of those other Chris's, we're ready to begin Kruskal's algorithm. So the way this is going to work is we're just going to ask Foxglove Chris to just list us one at a time the direct city-to-city routes in order from shortest to longest, and Foxglove Chris is very good at that. And then for each one, we're going to ask Oven Mitt Chris whether or not that route connects cities that are already connected. If Oven Mitt Chris says no, then we will place the train cars on that route. Otherwise, we'll move on. And we'll just continue like this until all of the cities are connected. All right, so let's start. So Foxglove Chris, what's the first city-to-city route we should consider? All right, Omaha, Kansas City. Oven Mitt Chris, are those cities already connected? Okay, so let's go ahead and place a train car on that route. Okay, Foxglove Chris, what's the next one? Okay, Dallas, Houston. Okay, Oven Mitt Chris, are they connected? Not yet, okay. And then, all right, Foxglove Chris, what's the next one you want to tell us about? Okay, Santa Fe, Denver. Are those connected? Not yet. Okay, let's place the route. Now, obviously, this is going to get a little bit tedious, so let's skip ahead. At this point, as you can see, all of the pairs of cities that are directly connected by a link of one or two train cars have been connected. So let's go ahead and continue the algorithm. So Foxglove Chris, what's the next route we should consider? Phoenix, Santa Fe. Okay. Oven Mitt Chris, are those already connected? Nope. All right, let's place the route. Okay. Foxglove Chris. Santa Fe, Oklahoma City. Oven Mitt Chris, not already connected. All right, let's connect them up. Foxglove Chris, give us another one. Salt Lake City, Denver. Okay, Oven Mitt, Chris? Not connected? Okay, we know what to do. Okay, Foxglove, Chris. Phoenix, El Paso. Oven Mitt, Chris? Are those already connected? Okay, they're connected already, so we'll skip those. Okay, Foxglove, Chris. Give us another one. Phoenix, Los Angeles. Oven Mitt, Chris? Not already connected. Okay. All right, Foxglove, Chris. Salt Lake City, Las Vegas. Oven Mitt, Chris. Is there already a path between Salt Lake City and Las Vegas on the trains that we've already placed? There sure is. Okay. Next one, Foxglove, Chris. Los Angeles, San Francisco. Oven Mitt, Chris. All right, we know what to do here. Foxglove, Chris. El Paso, Dallas. Okay, Oven Mitt, Chris. Are those cities already connected? They are. Okay, Foxglove, Chris. Oklahoma City, Denver. Already connected. Denver, Kansas City. Connected. Denver, Omaha. Connected. Phoenix, Denver. Connected. San Francisco, Salt Lake. Connected. El Paso, Oklahoma City. Connected. All right, looks like we're done. So at this point, we've got all of our cities connected, meaning if you pick any two cities in our little part of the world here, there is a way to travel from one to the other using those trains. And because we used Kruskal's algorithm, we are guaranteed that we have used the fewest possible number of train cars to connect up all of these cities. Now, that doesn't mean that there are other ways to do it with the same number of cars. So for example, right, it's pretty obvious that you could switch this to this one, right, connect Phoenix to El Paso instead of Phoenix to Santa Fe, and you would still be connecting all the cities and still use the same number of cars. But what we're guaranteed is that there is no way to connect all of these cities with fewer cars than what we have here. All right, so now you understand Kruskal's algorithm.